Need computer training for a group or office? Contact us today to get a free demo of our training at www.teachucomp.com/enterprise-licensing.
The relational model of data storage allows you to more easily and effectively model a complex entity or subject like sales. The relational model of data storage eliminates redundant data entry and also creates less data to store, making the relational database model smaller and faster than the flat file. When you create a relational database, you will first need to perform some data modeling. Data modeling allows you to ensure that you are recording all of the information needed and also helps you identify the entities involved and their relationships to each other. When you create a relational database, you need to identify the unique entities involved in the process that you are modeling. These entities will often become the various tables in your database. So, for example, in the sales database example from the last lesson, the customer is an entity. Within each table created for each entity, you must only list fields or columns of information which share a one-to-one relationship with the entity or subject of the table. So, for example, in a customer table, you would want to place the field first name, assuming that each customer only has a single first name to record. You would not want to place item into the customer table, as the relationship between the customer and the items purchased in the sale is one to many. So what would one do with the column of item? In the relational model, each field or column of information is an attribute of an entity. So for what entity is item an attribute? In other words, with what entity does the item, which is a description of the item purchased, have a one-to-one relationship? Perhaps you may initially think that the item is an attribute of the sale. However, could you have a single sale with multiple items ordered? Probably so. In that case, it must be an attribute of something else. In this case, item is probably going to be an attribute of an item entity, meaning that you will probably need to create an item table. Many times when initially approaching data modeling, it may be easier to list the various attributes that you want to record and then try to find what entities those attributes describe. The entities will become the various tables in your database. The attributes will become columns within the entities tables. Remember that each attribute or column in your table must share a one-to-one relationship with the subject of that table, or the entity. In either case, you should probably keep your information written down on paper until you have a rough idea of what information it is that you want to record about the various entities involved with the process or system that you are trying to model. It's a rare feat to have your preliminary sketch of the relational database tables turn out to be the finished model that you will actually create in Access. Many times you will need to create a model, look for problems with the model that you have created, and then edit the design until you're ready to attempt creating the tables. Let's take a look at a preliminary model of the sales database from the prior example. So first, make a listing of the various pieces of information that you want to record. These become the attributes of the various entities. Next, try to find what entities these attributes describe and list those too. Next, make some sketches of the tables that show the fields of information within them. This can help you start to visualize what tables you will need to create and will also allow you to see how the tables will eventually be related to each other in a larger relational database structure. Once you have a rough idea of what you would like to record and what tables you will need in order to record the information you need, you must then ensure that each table has what is called a primary key. A primary key is a column or a combination of column values that will produce a unique value for each row in a table. Many times, An additional column is added to the tables in order to provide this unique identification. You can assign each record a unique number within an ID column. For example, that is what your Social Security number is used for by the government. You have a unique driver's license number as well. If you were recording any of these pieces of information, you could use those as the primary key in the table. If, however, you aren't recording any type of unique information, then often you must assign your own unique values. Many companies, for example, assign customer ID numbers to uniquely identify each customer. Let's look at how your data model will change once you assign primary keys to your table. For example, you need a way to uniquely identify each customer. In the current data model, there isn't any kind of information that would enable you to uniquely identify each record or row within the customer's table. So you could add an additional field or column of information to this table named Customer ID. Assume that you then add another column for Sales ID to the Sales table and an Item ID field to the Items table. In the sketch shown, each primary key is shown in bold within the table diagram. So the data model would then look something like this. Now, the primary key is a very important concept in a relational database because it's through the primary key assignment that you create the necessary relationships between the data tables. For example, examine the relationship between the customers table and the sales table in terms of the one-to-one and one-to-many relationship. In this case, for each one customer, there can potentially be many sales. So the tables will share a one-to-many relationship. This is the most common type of relationship between tables with extremely few exceptions. What you need to do is find a way to join the many side of this relationship to the one side of the relationship. You need to relate each entry in the sales table to a customer in the customers table. In order to join tables, the tables must have a shared or common field between them. This would be a field that contains the same kind of data in both tables. So in this example, you are trying to assign each sale to a customer. To do this, you would want to add a field to the sales table that corresponds to a field in the customers table. Which field would you choose? The answer is the primary key field. Remember that each primary key field is designed to uniquely identify each record or row within the table. So you can add a field to the sales table that will make a reference to the values in the customer ID field of the customers table. That way, when you enter a record into the sales table in the future, you will only need to enter the customer ID number of the customer to whom the sale was made, practically eliminating redundant data entry. So you can see one advantage to the relational model. In this model, you only have to enter the customer's data once into the customer's table, and then assign them a unique customer ID. When you then enter sales for that customer into the sales table, you only need to make a reference to the appropriate customer ID in the sales table to indicate who made the purchase. This allows you to store much less redundant data, making the tables smaller and faster to use than the flat file table. It's also important to note that the customer ID field, which is added to the sales table, is not a primary key of the sales table. That table already has a primary key field in its sales ID field, which uniquely identifies each sale, like a receipt number. Technically, the field in the many table, which makes a reference back to the primary key value in the one table, is called a foreign key. Its only purpose is to relate the two tables, and the values within a foreign key are almost always non-unique within the column. Don't worry about the mechanics of the data entry, or how to create primary keys and table joins just yet. It will be explained in later lessons. For now, just try to comprehend the concepts and reasoning behind the relational database design. Let's examine how the table diagram has changed to reflect the newly created relationship between customers and sales. Next, you will want to examine the other relationships between the tables. For example, what is the relationship between customers and items? Don't be hasty. Not every table in the database has to be directly related to every other table. The only way that customers and items are related is that the customer purchased the items when making a sale. The customers and items tables do not have a direct connection. However, in a relational database, as long as every table is connected in an appropriate manner to the correct table, you can find out how they are related to each other through the tables by which they are connected. So in summary, the customers are connected to the items, but only through the sales table. So how are the sales table and the items table connected? Well, for each sale, there may be many items ordered. Also, each item may appear in more than one sale. In relational database design, you cannot, or should not, create a many-to-many relationship. That would make no sense from a strictly logical point of view. You need to be able to tell which items were ordered in which sale while reducing the amount of data entry. Also, you may notice another problem with the current data model. The amount field is attached to the sales table. In this context, this field would represent the sales order total. If that is the case, then how can you record the price of each item at the time of sale? What if the price of each item changes in the future? Is the amount also an attribute of the item? What you are starting to see is that you need to be able to link the unique sales records to the unique items ordered on each sale. You need a sales details table in order to do this. But what fields do you place into the new sales details table? The answer is anything that is an aspect of the many side of the sales transaction. For example, the sale date field can stay in the sales table because each sale only happens on one specific date. The quantity of the items purchased at the time of sale is actually part of the many aspect of the sale and should be moved to the new sales details table along with the amount field. The customer ID will stay tied to the sales table as each purchase is made by a single customer. So now examine how this new sales details table will affect the data model. So now we are examining a diagram of the new tables in the data model. You must also remember that the new table of sales details will also need to contain a primary key field. Before assigning the primary key field, look at how you will relate the sales table to the sales details table. The tables are related in that each sale may have one or more items purchased in each sale. So you need to join each record in the sales details table to the sale record to which it corresponds. To do this, you will add a foreign key into the sales details table that corresponds to the data in the primary key of the sales table. So you will add the sales ID field to the sales details table. Next, examine the relationship between the items table and the sales details table. In this case, for each item ordered in a transaction shown in the sales details table, it must make a reference to the unique item within the items table. So you will add the foreign key field of item ID to the sales details table. Then you can join the tables through their shared or common fields. So let's examine how the data table diagrams in the data model may look after performing these two tasks. Now you have created all of the necessary relationships between the tables. However, the sales details table is still missing a primary key field. You could add another field as the primary key, such as sales detail ID. However, you could also see if there is a combination of field values that already exists that, when combined, produce a unique row value. In fact, there is. The combination of sales ID plus item ID. There should never be a repeating combined value in those two columns. If there were, it would mean that the same item was recorded in the same order twice. If that were the case, it should only be recorded once in the sales details table with a 2 or greater recorded into the associated quantity field for that row. So assuming that you make this combination of fields the primary key for the table, let's then examine the data diagram. This is the final data diagram based on the information that was needed to record the sales. Obviously, there's more information that could be recorded, but this example is only supposed to illustrate some of the decisions that should go into table design before you begin to create your tables in Access.
Like what you see? Get a free demo of our training for groups of 5 or more at www.teachucomp.com/enterprise-licensing.